In this screencast, we're going to look at density, mass, and finding the center of mass. The idea is density. Oftentimes we'll use the symbol delta to represent density is found by taking a mass per unit volume. However, since we are most of the time working with curves, we're not going to be really dealing with volume. Instead, a curve has a length. So we're going to really be looking at a mass per unit length. And the idea is that you're taking small bits of mass and dividing them by small bits of length, and then taking a limit as the mass and the length approach 0, which really means that our little bit of mass is a density times a little bit of length, which actually gives us a way to find total mass. If the density of an object is not constant, then the mass is found by taking the curve, breaking it up into little bits, and adding up little bits of mass. But a little bit of mass is found by taking the density and multiplying it by a little bit of length. And that in turn is found by finding the speed and multiplying it by dt. So again, we're going to have to be finding speed fairly often in this problem. If the density is constant, then this integral right here, or integrate c delta ds, the delta can just be pulled out. And then this integral is add up little bits of length, which is just arc length. And so then you get mass as density times length. Now what we're going to do now is just use this to briefly develop a formula for the center of mass of an object. The center of mass of an object was the same thing we got by taking the centroid we got by taking the integral or averaging the x values with respect to s. This time we're just going to change the s's to an m, and that gives us essentially our formula for x bar. Y bar is, again, the same thing. Yep, that should be a y. And if you want z bar, then you average up the z values with respect to mass instead of just with respect to length. So that gives us our x bar, our y bar, and our z bar. What we're going to do now is we're going to use these formulas to just find the center of mass of a we're going to look at a circular half-circle arc, and we're going to let our density be x squared plus y, and our curve, r of t, equals 3 cosine t, 3 sine t. In order to proceed, I need the derivative, which is minus 3 sine t, 3 cosine t, and then I need the speed, which is the square root of, that would be 9 sine squared, plus 9 cosine squared, which is the square root of 9, or 3. So if I'm looking for a little bit of mass, which I'm going to need, that's your density times r prime dt. Well, the density we already know is x squared plus y. So this is x, that's y. So I'm going to have to take 3 cosine t squared plus y, which is 3 sine t. And that takes care of my density. The speed is 3, and then I'll have a dt. So if I want to find x bar, the answer is simply integrate. If I'm going to go around this thing halfway, then my bounds are from 0 to pi. The x value, if I want x bar, I need an x value. So the x value is 3 cosine t, and then I need my dm, which is 3 cosine t squared plus 3 sine t, all that needs to be times by 3 dt. Then I divide by everything that's identical except I remove the x. So then I'm just going to divide by this quantity with the x removed. 0 to pi, 3 cosine t squared plus 3 sine t times 3 dt. If I want to get y bar, then the way I get y bar is I repeat the above and everything is identically the same except rather than using an x, I use a y. So that's a 3 sine t, and then I have the 3 cosine t squared plus 3 sine t times 3 dt all over. The bottom remains the same, 3 cosine t squared plus 3 sine t, 3 dt. And that completes this example.